By using the gradient and also the scalar state to extract the ray length, you will be able to modulate the factor based on distance. One big advantage of the gradient is it has what we call a built-in change range, so you can adapt the effectiveness of this modulation based on distance. And also, whenever you type in value, whenever the input is outside of 10 and 20, the gradient is designed to hold the last value. So if it goes to 0, and it will keep using 0 until whatever value. So this is one of the big advantages of using the gradient in this case. One of the other technique actually to use this is by using the change range. The only drawback using change range is that it will not hold the last value whenever it is outside of the range. It will actually extrapolate it, so you can have what we call overshoot value. So you have to basically what we call implement some sort of a clipping functionality with the change range. So the input, let's say, would be 10 to 20, and the actual bump range will be, whenever it's 10, I want to have a bump of 6. Whenever it's the actual distance is 20, I would like to have a bump 0. But if I type in, let's say for example, if the input is 25, then I will start to get into negative value. So let's do a render region just to show this in action. Now we start to have the bump map to appear, and we may need to actually change some of these values to make it. Et voila. Now we see that the actual bump map goes towards 0 and start to have negative value based on distance. So this is a proof that the change range is not doing any sort of clipping, but more like does a change range and keeps the extrapolation occurring whenever the actual input range is outside of the old range being defined by the user. One way to do this is by using the scalar mat node to implement your own clipping to values. So we could say, okay, the active clipping is 0, so we could say mat scalar, let's say we could say basic, for example. Voila. If I connect this one to input and I say I want to say give me the minimum value, so if I give you, let's say 6, so whenever it's greater than 6, it will always return 6. So this is a clamp to 6 value. Now if I actually move this value here, get another shader like this, and I say maximum 0, then whenever the value is below 0, it will return 1. So now I can actually copy the shader right here, and let me just actually move these shader right here. Voila. Now we'll connect this one directly to bump factor. Now we'll have a bump effect that still occurs as we defined, but here all this negative bump will basically disappear. Voila. Now we're forcing a clamping by using other nodes to clamp the values, and this is another way actually you can modulate the effect and really control how the actual remapping is being done in the scene. Thank you.